Hello student, this is your chemistry faculty Karthikeya Raj, and my dear student, in the previous episode, in the previous lecture, we have discussed lot of concept. But in this class, we are trying to focus on the bond formation, the different type of the theories. So your first responsibility is to just open your notebook and just understand the concept. Okay? So the topic is bond theories. In chemical bonding chapter. What are the theories? What we have to study, guys, that how the chemical bond is going to form, that is the most important part. So the first theory which I am going to clarify is octet rule. Every elements wants to acquire inert gas configuration except hydrogen. To achieve high stability, here you say maximum stability, elements can share 1, 2, या 3 electrons to form chemical bond. So what was the concept of octet rule? Octet rule mainly focus that any chemical bond is going to be formed, it is only due to the sharing of electrons, because we are going to discuss here the covalent bond, student. And they want to maintain octet, 8 electron in the last cell. So how the 8 electron can be acquired? It can be acquired by the sharing. Okay, so see the various example which obeys octet rule. For example, you take CH4, you take carbon tetrachloride, ammonia, you take phosphine PS3, you take it S2O, and so many. How it follow the octet rule, guys? Let I have to clarify. Carbon having the 4 valence electron, no issue. Now take it the hydrogen. Hydrogen has the 1 valence electron. Now see, guys, hydrogen want to maintain duplet such that it acquires the inert gas configuration of helium. So every hydrogen want to acquire duplet, duplet, duplet. Now what happened, guys? This carbon in the initial time is having only the 4 valence electron. Now once they shared, now the total number of valence electron, yeah, you say total number of electrons become equal to 8. So due to this sharing beta, what happened that total number of electron in the carbon become octet, and in the case of hydrogen it become duplet. So both of them to become stable. And that was the concept of the octet rule. Octet says that if you have 8 electron in the last cell, it means that that is a stable configuration. Okay. Now see the question CCl4. Example, carbon having the 4 valence electron, chlorine having the 7 valence electron, guys. Chlorine having the 7 valence electron. Now see, again, what is the main perspective of octet? Every atom wants to acquire 8 electron into their outermost shell. Now see, this chlorine is having only the 7 electron. So this mentioned to carbon, ki brother carbon, will you give me the 1 more electron such that I maintain the octet? Carbon mentioned, no issue, you just take my valence electron. Now guys, due to this chlorine is having the 8 valence electron. Again, chlorine acquire 8 valence electron. Again, octet maintain. Again, octet maintain. But due to all these things, beta, carbon also acquire the 8 electron into their valence shell. See how we find carbon acquires 8 electron. Now see guys, 2 electron, 2 to 4 to 6 to 8 electron. So what is the total number of valence electron in the carbon also? It become equal to 8. Are you getting my point? Now see, question, take example of ammonia. Ammonia consisting of 5 valence electron, your Bell family. Hydrogen you place here. I have already told that how you have to draw the Lewis dot structure. Now what you have to do? Hydrogen wants to maintain duplet. Hydrogen wants to maintain the duplet. Duplet already achieved. Now nitrogen wants to maintain octet. How it could be possible? It is only possible when nitrogen will take also the electron of hydrogen. Now see guys, what is the total number of electron in the nitrogen? 2 to 4 to 6 to 8. So total number of electron in the nitrogen is also become equal to 8. It means that this structure is obeying the rule. This a structure obeys the octet rule. Are you getting my point, student? Very easy concept. Now see the another question. Let's take some other example. Like already I have taken PS3. The name of this compound is phosphine. Okay guys? Now phosphorus also consists of 5 valence electron. Take it 5 valence electron. 3 hydrogen arranged sequentially, which I have told earlier, that how you have to draw the Lewis dot structure. Now you just put hydrogen here and 1 valence electron. Okay. What you have to do? You have to maintain the duplet of the hydrogen such that it acquire the inert gas configuration just resembling to that of the helium. Now see beta, this phosphorus also want to take the electron of hydrogen, once they take the electron of hydrogen, what is the total number of electron in the phosphorus? You find 2 plus 2 4 plus 2 6, 6 plus 2 8. So here, sir, it is also obeying octet rule. Are you getting my point, guys? So in examination, how the questions arise? Questions arises in this way, that which of the following a structure is obeying, which of the following option is obeying the octet rule. For example, if you take PCl5, so again the central atom is the phosphorus. You take it phosphorus as central atom having the 5 valence electron. And guys, you find 7 chlorine having the 7 valence electron, not 5 chlorine, sorry. Again, you take it the chlorine. Now see, what you have to do, this chlorine wants to acquire the octet. It maintains the octet configuration. It also maintains octet. This also wants to acquire octet. This also acquires octet configuration. This also acquires octet. What you find, the chlorine, which is behaving just like the ligand, yeah, you can say not ligand beta, you say the chlorine, which is the attaching part, they maintain their octet by the sharing of electron. But what happened if you just take the phosphorus? The phosphorus also take the electrons of all the chlorine. Okay, no problem. They take the electron. Now you see, what is the electrons that the phosphorus have? 2 electron, 2 plus 2 4, 4 plus 2 6, plus 2 8, plus 2 10. So now this phosphorus is having the 10 valence electron, guys. Still, it is stable and also exists If you take example of beryllium fluoride, say you find beryllium having the 2 valence electron, fluorine having the 7 valence electron. Now see guys, what the fluorine wants? Fluorine wants to maintain the octet. Fluorine maintain octet, no problem, na? Again, this fluorine also wants to maintain the octet, no problem. But see, the beryllium also wants to maintain, to complete their not octet. You find, sir, this beryllium is having only the 4 electron. Here, fluorine maintain octet, maintain their octet. But if I am talking about the beryllium, so it has only 4 electron. But we can see that do not maintain octet. It means that, sir, this structure is not obeying the octet rule. This structure also not obeys the octet rule. But it has been experimentally found beryllium fluoride is stable and it also exists. It means that for any compound formation, for any covalent compound formation, the octet rule is not only the criteria to decide is it stable or not. octet rule is only the part which can give the idea that this is the primitive features, these are the certain assumptions which I am just going to consider for the bond formation. Getting my point, guys? Okay. Now see, now coming to the limitation of octet rule. The first part is the hypovalent molecule is the first exception. What is the meaning of hypovalent molecule? Molecule having less than 8 electron in their valence shell still exist and stable also, guys. For